Section 2.1 is called Reasoning and Logic, and as we get started in this section, we need a little bit of vocabulary. Some of this vocabulary is going to be very familiar to you. Some of it is probably not, and it's things you've done before. You just may not have put this label on them. So let's take a look together. The first thing we're going to talk about is what a statement is. A statement is simply a sentence that's either true or false. So, for example, a statement would be something like, I ate eggs for breakfast. Okay? It's either true or it's false. Now, you may not know if I did or didn't, but it is a true or a false statement. There's not sort of an in-between statement that can be made about that. It's either true or it's false. A non-example of a statement, there's a couple of them that I could show you. I'm going to show you one of them. One of them would be something like this. What did I eat for breakfast? What's wrong with this particular item that I wrote down? It's a question. And the real problem with the fact and why it doesn't work is because it's neither true nor false, right? I can't say that's true or that's false. It doesn't even make any sense to talk that way. Besides questions, the other thing that can end up being not a statement are commands. Something like, eat your breakfast. Well, whether the child eats his breakfast or not may or may not actually, be a statement. But you telling them, eat your breakfast, is not a statement. It's a command. So this is a sentence that is either true or false as a statement. All right, a negation is the logical opposite of a statement. If a statement has written as a letter P, for instance, a negation would be written tilde P. Okay, so this is one of those curly symbols that's usually in the top upper corner of your keyboard, where the one key is often. It's called a tilde. And it's read, like when we read this, I sometimes will probably say tilde P, but it's supposed to be read not P. Okay? So, this is pretty easy when we have a statement like, I ate eggs for breakfast. What would the logical equivalent, what would the negation be for I ate eggs for breakfast?
I didn't.
Yeah. The negation would be, I did not, or I didn't, either way. I did not eat eggs for breakfast. Now, you might look at that and say, well, that seems very obvious. All I have to do is to change something that's said in a positive way to say it in a negative way, or vice versa. And in many statements cases, that's true. That's all we have to do. However, there are some statements that make it a little bit trickier for us. And those statements are statements that have what are called quantifiers. So there are two types of quantifiers. The first type of quantifier is a universal quantifier. So it refers to each and every element of a set. It uses words like all, every, no, and none. All children should learn to read. All people can do math. No one likes being in trouble. Okay, statements where you use the phrase all or no. Okay, every child in my school comes from Shawnee. Okay, those kinds of statements. Now, the opposite of that is actually something that's called an existential quantifier. And this refers to one or more than one elements in a set, and it uses a phrase like there exists, some, at least one, those kinds of phrases. So you hear things that sound quite different, like at least one child in my class cannot read. There exists a child in my class who does not live in Shawnee. Okay? sounds very different because all it has to have in it is one or a few, whereas the other quantifier is like all-encompassing. It's the case that your mom told you to say, don't ever say never, never say never, right? You know the phrase? Or, it's usually a bad idea to say, you always, da-da-da-da, because nobody always does whatever. That's the universal, okay? The existential is leaving you an out. It's leaving you a case where maybe it didn't really work out the way you thought it was going to, kind of thing. So we're going to write down a couple of these that I've said a few of them out loud, but for example, a universal quantifier inside of a statement might look like something like this. All boys love their mama. Now, if you think about this statement, I'll write the existential one in a moment. The opposite of this statement is not that no boys love their mama. That's not the opposite of this. Would that be something that's sort of counterproductive to what that statement was? Yes, but it's overkill. It's overkill. The only thing that has to happen for this statement to be false is what? One boy that doesn't, right? That's all I would need. We were talking about counterexamples in the last chapter, right? Counterexamples. All I have to do is have one thing that shows the statement's false. Well, that's just what a universal quantifier or what a negation does. A negation changes it just enough that makes it false. It's the bare minimum that I need. It's the counterexample. All I need is that one child to make that a false statement. Universal quantifiers can be changed to negations using existential quantifiers. We'll talk more about in a minute. An existential quantifier example would be something maybe like this. Some people like swimming. Now, if we were trying to do a negation on this, sometimes I will have people say something like, some people don't like swimming. Well, that's actually not the opposite of this statement at all. I can have some people like swimming and some people don't like swimming, and I still have the statement on the board that's true. I mean, I don't have to have everybody liking it to make this statement true. I just have some people, okay? So if I'm changing this one and I want to turn it into a negation, I actually have to change that word some into all or every or something like that. So all people don't like to swim. Or you could say something like nobody likes to swim. The statement turns into a universal quantifier kind of statement when you're working with that. So there's a statement right here, the note that's sort of hitting on what I've been saying is that when you have negations of quantifiers involved, things get a little bit trickier. You have to be really careful with those quantifiers because they change. So we're going to do a couple of examples of this. The first one is all dogs go to heaven. So the question is, well, the first thing to notice when you're dealing with these statements is to sort of note to yourself, do I have any quantifiers? Do I have any universal or existential quantifiers? And do I in this one? I do. What's the word? It's the word all. And as a general statement, the issue with the word all is that it's a what kind of quantifier? It's universal. So I have a universal quantifier. In order to negate this statement, I cannot use another universal quantifier. I need to make a existential quantifier. So I'm going to replace the word all with the word some, or there exists one, or at least one, or something of that nature. Okay? So
Did you say most?
we don't need most. We only need one.
Yeah, but like, just as an existential quantifier in general, could you say most?
Like if you saw the word most, would it be existential? It would. It would. I don't think that it works to turn it into a negation from there, but if you started off with that statement, could you work from that statement and create a negation? Yeah, you could. I don't think anybody's ever asked me that before, though, so I'm not sure I've seen the book at least do that. Yeah. I spelled the word there wrong, too, since I was talking. This is the word there I want. There exists. That's the one I'm going to use. If you use the word some or at least one or something, that's fine, too. It doesn't matter. I use the phrase there exists. All right, there exists a dog. That's all I need, just one, right? I just need one. There exists a dog that what? Yeah, that doesn't go to heaven. There exists a dog. That's very sad, I know. There exists a dog that does not go to heaven. Now, the one that I just wrote down is kind of wordy. It'd be a lot quicker, a lot shorter, cleaner to say something like this. Some dogs don't go to heaven. That would be a much more direct way of saying what I did. Not any less correct or more correct, just a different way of saying it, a little bit more concise. So there has to be one, there exists the dog that doesn't, that this statement does not apply to. All right, part B says some of my classes this semester are hard. Do we have a quantifier here? We do. What is the quantifier? Some. And most of the time our quantifiers are at the beginning of a sentence. They don't have to be, but usually they are. Is this universal or existential? Existential, okay? So I need to change this into a universal quantifier. And I have choices. I can change this so that it says all, or I could change this so that it says none. And I can write the statement either way. So I'm going to do both of them just so you can see what they would each look like. Often there's one way of writing that's just more natural than the other one. But let's actually give it a try with the word none first and see how that one goes. So some of my classes this semester are hard. None what? What am I going to write next? Yeah, this one's really clean because it's almost identical. We just have to change the first word if I start with none. None of my classes this semester are hard. Do you agree? That's the exact opposite of what the statement originally said. Okay? Let's write it one other way, just in case you happen to think about this as you're working through other problems. We could start out with, instead of working with the word some, all. If I start out with the word all, what am I going to have to say next? You're very close. So all of my classes this semester, I don't want to say are easy. Any idea why I don't want to say are easy?
That doesn't technically, they don't have to be easy, they're just not hard.
Yeah. Have you ever had a class that's neither easy nor hard? It's something sort of in between. I mean, these are not sort of opposite things. Like you don't have to just be easy in order to be not hard. There is at least some category, at least the potential there's something in between. So we're going to be careful when that's a possibility that we're very clear with the words that were already used, just to keep those words that are already in there. So something like this: all of my classes this semester are not hard. You guys with me? We don't want to change something to mean a more drastic statement than what it originally did. We want to keep the language as close as we can, change the least amount that we can change. All right. Truth tables. All right, what truth tables are simply like an organized listing of something, is what it is. It's an organized list. And what they do is they're used to show all possible true-false patterns for statements. Okay? And we're going to start with a very, very simple truth table. And it's a negation truth table. So here's the way truth tables look. They kind of look like a T-chart, like an XY axis or something like that. And over here, whatever my statement is, we'll call it P, is my statement. I have a column for P. So remember, columns go up, down. We're going to do a column like that. And then I'm going to do the next column that's going to be the negation of P. Remember that tilde that we had before? Not P. So a statement, remember our definition of statement is that it's a sentence that's either true or false. Those are my only two options, right? So if the statement is true, we would say it's capital T. Use capitals for me so that there's less likely to be questions between your T's and your F's, hopefully. And be really careful with your F's and your T's that they look distinctly different. So if you have a statement, it has two choices. It's either true or it's false. Now, if your original statement is true, what would the negation be? False. And if your original statement is false, then the negation would be true. So this is a truth table showing negations. Okay? Now, it's not very interesting because there's only one statement in the truth table, P. So what happens if we had more than one statement? Well, that has a name. It's called a compound statement. A compound statement is simply two statements joined with a connective. And some examples of connectives are and, or, and if then. Those are the three that we're going to focus on. Occasionally you'll see a connective like the word but if you think carefully about the statement, you often can realize, oh, it just means the same thing as one of the other ones, right? Like, I was late this morning, but so was the person I was supposed to meet. Well, that but really just means and. You know, it's basically making, a statement that's a compound statement with the word and in between. So these are the three that we're going to have focusing on. The first one we're going to talk about is called a conjunction. A conjunction is a statement with and in it. Okay? So two statements that are combined with the word and in between them. Like, I'm a mom and I'm a teacher. That's all it is. It's just two statements put with the word and put between them. I'm going to show you what the truth table looks like for that, and we'll argue through it a little bit so that we can see that it actually makes sense. Now, in order to have a truth table with two statements, I'm going to need two columns. A column for statement number 1, we'll call it P, and a column for statement number 2, we'll call it Q. And don't ask me why P and Q, but those are the conventions that you usually see used, is P and Q. I'm going to stop with my columns. We'll come back to the columns in a moment. But what we're going to look at first is just all the possible truth values for these individual statements. For example, the way that we started before is we said, oh, well, our truth statement for P is that it could be true. And it could, right? Whatever statement P is, it could be true. Well, statement Q could also be true. So you could have both statements that are true at the same time. But you could also have the first statement true and the second statement false. Or you could have the first statement false and the second statement true. Or you could have both statements false, like so. Now, this pattern is the same every single time you have two statements. So I sort of argued through why I put T's and F's where I did, but the reality is that when you get to this problem and you're doing a truth table, you can always write T, T, F, F, T, F, T, F, and be done with those two columns. You can always do that much of a truth table because it's the same no matter what truth table you have. Okay? So the next column, though, I'm going to do is going to represent this conjunction. So what in the world does this conjunction look like? Well, I haven't actually written it in, so let me write it in over here. A conjunction has the form where it has the P and the Q with it, and in between it looks like an upside down V. And this statement is P and Q. It almost kind of looks like a pointy N or something like this, or an A without the line in between the middle of it if you prefer. So over here I've got P and Q. So what I'm going to do is I'm going to argue through a couple of statements here for a moment with you. And my two statements that I'm going to argue through, you can write this down to give yourself a reference if you want to look back at it later, are the statements I just gave you a minute ago. I am a mom. And the second statement that is I am a teacher. Or actually, let me use I teach math. That'll make things easier. Okay, so here's the idea. I come into the classroom. I'm the first column, okay, or the first row. I tell you I'm a mom and I teach math. Okay, both of the individual statements are true about me, correct? So if I use those two statements and I put the word and in between it, is the statement still true? Yes, it is. Because both of the individual statements are true. So when I combine these two with and, I get a true statement. Because both of the individual statements are true. All right. Let's use... Mrs. Dr. Gregory, is she a doctor? We'll use Dr. Gregory. Do you guys know Dr. Gregory? Okay. We'll use Dr. Gregory. Is she a mom? I should have used woman. That would have been easier. She has a daughter. Okay, fabulous. All right. I usually try to use people you guys know, so every time I do this in class, I try to change my people around. Okay, so we're going to use Dr. Gregory. So if Dr. Gregory comes in here today, and she says, I'm a mom and I teach math. Well, the mom part, according to Amanda, hopefully, is true. But if she says the I teach math part, that's not what she teaches, right? She teaches something different. So if she puts those two statements together with the word and in between them, is it a true statement? It's not. It is a false statement. Because she doesn't do both. All right. If Dr. Camp, do you guys know Dr. Camp? No. Tell me one of your male professors. Give me somebody's name.
Bandy.
Dr. Bandy. Okay. Do you guys know Dr. Bandy? Okay. If Dr. Bandy comes in, actually, I totally messed this up. We're actually on the last column now because I picked Dr. Bandy. So we'll keep going with Dr. Bandy. Dr. Bandy comes in and he says, I'm a mom and I teach math. Both of those statements are actually false already, right? Individually false. So that's my fourth row, actually. That would be combined to be a false statement as well, right? Yes. All right, so let's do the one in the middle. And I'll do Dr. Tucker, actually, would work. I don't know if you guys know Dr. Tucker, but Dr. Tucker is actually a female math professor, but she's not married, doesn't have any children, okay? So if she comes in and she says, I am a mom and I teach math, she does, in fact, teach math. That part's true, but she's not a mom, okay? So if she comes in and she says, I'm a mom and I teach math, then the answer would be false. It's still false. So taking a look at this conjunction as it is, what you notice is that the only way a conjunction is true is if both statements are true. Right? The only way it's true is if both statements are true. Now, that actually is not what's going to happen when we get to the next one. Disjunctions are statements where we put the word or between them, and they don't have that feature going on. They are different. And we'll pick up there next time.